Hi everyone, I wanted to make this video today to talk a little bit more about some confusing things about rational expressions. I put together a little bunch of examples here. I'd like to start off with some rational expression hints and strategies. The number one hint here is to start by knowing all of your background information. So you have to be very, very good at factoring. If you're not very good at factoring, that might be something that you want to review right now, so that when you that's not the hang up when you're starting to do these problems. The second thing is to make sure that you know what the problem wants you to do and then have a very, very good checklist of steps for each type of problem. So I've put together some examples below. We can talk about a couple of these problems and maybe I'll split this into two videos. But the first one asks, what makes the expression undefined? That is where you're trying to figure out what makes the denominator equal to 0. So sometimes that's easy. Like in this first case, it's pretty easy. I can see that x equals 2 makes this equal to 0. So that's just a straight up answer. I just have to say, well, what makes this undefined? X equals 2 makes this undefined. The other one maybe is a little bit harder here because this I can't right immediately see what makes that denominator equal to 0. That's where those factoring skills come in. So I have to spend the time here and say, well, 18, that's 3 and 6. But that 3 in the middle is positive, so that must be plus 6 and minus 3. Using my skills from the last chapter, I can tell you that these answers are negative 6 and 3. So what makes that second expression undefined? Negative 6 and 3. Moving on, if you're told to simplify, that's kind of the same thing as asking to reduce a fraction or put the fraction in lowest terms. So your job here is to factor and cancel. The main mistake that people make here is that they try to cancel terms. They don't do that factoring step up front. So I just want to remind you that you do have to factor first. When I factor this numerator, it looks like I can take out an x squared, so then it's x plus 3. The denominator, well, that's already factored, just a plain old x plus 3. Those factors cancel, and I end up with just an x squared as my answer. If I'm asked to multiply, that's just a version of simplifying, honestly. You're just going to factor everything and cancel. And you cancel a top with a bottom always. Doesn't matter if it's up and down or diagonal, but you're going to factor everything and then cancel. Factor, cancel. So this first part of the expression, x minus 7 over x minus 1, that's already factored. But how do I factor that numerator? Well, that's difference of squares, x minus 1, x plus 1. How do I factor that denominator? Let's get a GCF of 3. So now I can just start canceling. Those x minus 7's cancel, the x minus 1's cancel, and this is just x plus 1 divided by 3. Dividing is almost as simple as multiplying. You just have to remember that you have to flip the second. So I'm just going to write flip second and then use multiplication techniques, which would be factoring and canceling. This one maybe isn't as easy because this first expression isn't completely factored, but it factors into x minus 1 times x minus 1. The denominator has a GCF of x, so that's x squared plus 1. I'm going to keep the division sign here while I factor that numerator. So I'm going to get x plus 2, x minus 1, and then that denominator, that 3 factors out, so I get x squared plus 1 there. But this is still a division problem, and I can't cancel up and down unless I have it written as a multiplication problem. So I'm going to take this time to rewrite this x squared plus 1 into a multiplication problem, which means that I take the reciprocal of that second term. I flip it upside down, x plus 2, x minus 1. Now I can start canceling any top with any bottom. I think that's it. So I end up with 3 times x plus 1 in the numerator, and then I end up with x times x plus 2 in the denominator. And I'm not going to multiply it out. I don't have to. I'm just going to leave it like that. If I'm being asked to add or subtract and I have the same denominator, hey, that's easy. I just combine those numerators. You may have to be a little bit careful about negative signs. You want to make sure that you're distributing that negative sign through that second term. So this would become 5x plus 1 minus 4x plus 2, because that negative sign distributes to that negative 2, over x squared minus 9. Combining like terms, I'll have x plus 3 over x squared minus 9 but then we have to make sure that this is in lowest terms to end with. We can see that this denominator factors into x minus 3, x plus 3, because it's difference of squares, and then these terms will cancel. So my final answer here will be 1 over x minus 3. If they have different denominators, can't do anything until you get the same denominator. So finding what an LCD is a technique that you have to have. Maybe we can do another video or have some individual talks about what the LCD is. But if you remember, the LCD has to include all of the factors. So the LCD here is x plus 1 times x minus 1. What is this first term missing? This first term is missing in x minus 1. So I'm going to add that in. X plus 1, x minus 1. That's a minus 1. And the second term is missing in x plus 1. So I'm going to add that in. And I didn't try to cloud this with any negative signs here, but remember, if that is subtraction, you would have to distribute that negative. When I put these numerators together, I end up with 3x minus 3 plus 5x plus 5 all over that whole long LCD, x plus 1, x minus 1. Combining like terms, that gives me 8x plus 2 over x minus 1, x plus 1, and of course I would try to simplify that, but I can't in this case, so that's my answer. Finally, what if we don't have the same denominator? Well, you still need an LCD, but you may end up having to factor. Here I can take out a 5x, and that gives me x plus 3. This factors into x plus 3, x plus 3. So remember, I have to include all of those factors. And in this case, my factors are 5x, x plus 3, and then a second x plus 3. So this LCD is the 5x plus both of those x plus 3's. So again, I say, what's missing in this first one? Well, it's missing one of the x plus 3's. So that will be what I multiply by over that whole denominator, x plus 3, x plus 3. What's missing in the second one? Well, that's missing the 5x. Again, over that whole denominator, x plus 3, x plus 3. So I can combine those numerators, and I'll get 7x plus 21 plus 45x over that whole long denominator. Let's just cheat a little bit and write LCD there. So when I put the 7 and the 45 together, because those are like terms, 5x, x plus 3, x minus 3. And I should try to simplify that as well, but for now, we're going to call it done. How about those complex fractions? Well, in this case, we want to multiply every term by the LCD. Our goal here is to get something simpler, and we're allowed to do this because of something called the identity property. We know back when we had, when we were just working with fractions, and we had a fraction like 2/3. If we wanted to get an equivalent fraction, we could multiply it by something like 10 over 10 to get that 20 over 30. These two fractions had the same exact value because 10 over 10 just equaled 1. So you were just multiplying by a version of 1. In this case, we're going to carefully choose our version of 1 so that our denominators cancel out. And the version of 1 here is the LCD of 4x. So everything is going to go by that 4x. I can show that over 4x times 1 over x plus 4x times 3/4. And the idea is here I'm going to be able to cancel out those x's. I just get a 4 there. I can cancel that. That's 6x. I can cancel those x's. I get a 4 there. And I can cancel that 4. That's 3x. You know, again, try to simplify, but for our purposes, that's finished. This next example is going to have us multiply by an LCD, but it's going to be a little bit maybe more difficult to find what the LCD is. I'm looking at this, I'm saying, well, here's a denominator and here's a denominator, but that kind of looks like a denominator too. But remember, we're looking for denominators within this fraction, some of those individual denominators, not the overall denominator. So I can see that this LCD here is going to be x times x plus h. So everything goes by x times x plus h. So here we go. X plus h times 1 over x plus h minus x times x plus h times 1 over x all over x times x plus h times h. When I cancel these things out, I just end up with an x minus x plus h as a quantity all over xh times x plus h. I can distribute this negative sign through here, so I can see that I'm going to end up having x minus x, which is, you know, just nothing, they cancel. But I end up with a negative h on the top, which would then be over xh times x plus h. But then these h's cancel, and I end up with a negative 1 over x times x plus h. This is a really long way of getting there, but that is my final answer there for that. What's next? Oh yes, maybe just one more example of these complex fractions where it's a little bit harder to see what the denominator is. Here there's actually really only one denominator, that's the 3. So that is my LCD. Remember, I'm multiplying by a version of 1, 3 over 3. So I have 3 times x over 3 minus 3 times 1, 3 times x minus 3. So these cancel, and my numerator just becomes x minus 3 over 3 times x minus 3. Those factors cancel, and I end up with a final answer of 1/3. So I hope this video was helpful to you. I would encourage you to go back into Canvas and also look at some of the instructions that I put in there. I don't want to make this one too long. And if you have any further questions, please feel free to send me an email. We can set up a time to Zoom.